The morning of January 17th, 1944, was bitterly cold at the General Motors Proving Ground in Milford, Michigan. Frost covered the test track as a small group of engineers watched a modified M4A3 Sherman lumber across the hard-packed snow. This wasn't an ordinary Sherman. Ballast weights had been bolted throughout its interior, pushing the tank's weight from 34 tons to over 41 tons. Captain Robert Harrison from the Ordnance Department checked his clipboard as the Sherman completed another circuit. The engine temperature gauges held steady. The suspension, groaning under the extra weight, had survived 500 miles of punishment over the standard endurance course. Most importantly, nothing had broken catastrophically. Harrison turned to the civilian engineer beside him, a metallurgist named Thomas Beckwith from Fisher Body Division. "Your assessment?" Beckwith nodded slowly, his breath forming clouds in the frigid air. "The M4A3 can handle it. The Ford GAA engine has the power. The suspension will take the load if we add extended end connectors to distribute ground pressure. The final drive ratios will need adjustment, but structurally, the tank can bear 42 tons of armor." What neither man fully grasped in that moment was that they had just proven the feasibility of something the United States military desperately needed but couldn't seem to produce: a heavily armored assault tank, a Sherman that could lead attacks through the most heavily defended positions in Europe, a tank whose armor could stop the dreaded German 88mm gun that had been tearing through Allied armor since North Africa. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of the Sherman Jumbo didn't begin in Michigan. It began 2 years earlier, in the deserts of North Africa and the rubble of Italian towns, where American tank crews learned a brutal lesson. The standard M4 Sherman, for all its reliability and mechanical excellence, was vulnerable to German anti-tank weapons. The 75mm PaK-40 and the legendary 88mm gun could penetrate a Sherman's frontal armor at combat ranges. Crews who survived hits spoke of the terror of watching an 88mm shell punch through steel plate that was supposed to protect them, the catastrophic secondary explosions as ammunition ignited, the desperate scramble to escape a burning hull. By late 1943, Allied planners preparing for the invasion of Europe understood they needed something more. The beaches of Normandy would be defended by concrete bunkers, concealed anti-tank guns, and determined German infantry with Panzerfausts. The hedgerows beyond would channel American armor into kill zones where Panthers and 88s waited in ambush. The standard Sherman could perform admirably as an infantry support vehicle and in tank versus tank combat at favorable ranges. But leading an assault, breaking through fortified positions, that required armor thick enough to absorb punishment that would destroy a normal tank. The obvious solution was the T-26 heavy tank, later designated the M26 Pershing. Development had been ongoing since 1942, and the design showed promise: a 90mm gun, armor comparable to German heavy tanks. But production delays and testing setbacks made it clear the Pershing wouldn't reach Europe in time for the invasion. The army needed an assault tank by summer 1944. They had perhaps 6 months to design, test, and manufacture a vehicle that could save thousands of American lives. The question was how to produce something that met requirements nobody had quite figured out how to satisfy. The British had faced similar problems earlier in the war. During a meeting at the United States War Department on February 21st, 1942, British tank mission representatives, including Michael Dewar, had suggested creating a heavily armoured infantry tank. They proposed modifications to the Churchill, or possibly developing something entirely new based on American tank chassis. The discussions produced the T-14 heavy tank project. On paper, it looked promising: thick armour, a powerful gun, the protection needed for assault operations. But the T-14 proved a disaster. Weight issues plagued the design. The armor configuration created problems with the suspension. Mobility suffered. Reliability was questionable. By early 1944, it was clear the T-14 would never see combat. The project was terminated, leaving the Army with a critical capability gap and an invasion date that wouldn't wait. In December 1943, someone in the Ordnance Department proposed an idea so simple it seemed almost obvious in retrospect. If they couldn't design a new assault tank in time, why not modify an existing one? The M4A3 Sherman with its Ford GAA V8 engine was the most powerful Sherman variant. The M4A3 was reliable, well understood, already in mass production. What if they simply added more armor? The concept violated conventional tank design wisdom. You couldn't just weld extra steel onto a tank without consequences. The added weight would overtax the engine, destroy the transmission, snap the suspension, and create a vehicle that could barely move. Or would it? That was the question that brought Captain Harrison and Thomas Beckwith to the frozen proving ground in Michigan. The test tank loaded with ballast weights was essentially asking whether the M4A3's mechanical components could handle assault tank loads. After 500 miles, the answer was cautiously affirmative. On March 2nd, 1944, the Ordnance Technical Committee met to review the test results. The atmosphere in the conference room was tense. D-Day was scheduled for early June, just 4 months away. Every day of delay meant American soldiers would hit those beaches without the armor support they desperately needed. The committee chairman, General Gladion Barnes, looked around the table. "Gentlemen, we have test data showing an up-armored M4A3 is mechanically feasible. The question before us is whether to proceed with limited production." One of the engineer representatives raised a hand. "Sir, we're talking about welding significant amounts of additional armor plate to production Shermans. The modifications aren't trivial. Quality control will be critical. Any flaws in the welds could create weak points that negate the protection we're trying to add." Barnes nodded. "Understood. But we don't have time for extended development. We need this tank in Europe by August at the absolute latest. Realistically, we need it sooner." Another officer spoke up. "Sir, isn't this just a stopgap? Once the Pershing enters production, the Pershing isn't ready." Barnes interrupted. "We've been waiting for the Pershing for 2 years. We can't wait any longer. This modified M4A3 is what we can actually produce in the time available." The debate continued for another hour, but the conclusion was inevitable. The committee recommended that the M4A3 tank with heavier armor be designated medium tank M4A3E2. The E stood for experimental, a designation that acknowledged the unconventional nature of the project. An initial order was placed for 250 assault tanks, plus 4 pilot vehicles for testing. On March 23, 1944, the order was officially approved. The contract went to Fisher Body Division of General Motors Corporation, whose Grand Blanc tank arsenal in Michigan was already producing M4A3 Shermans. Fisher Body was an unusual choice for tank production. Before the war, they had been automotive body manufacturers, specialists in forming sheet metal for cars and trucks. But the massive industrial mobilization had transformed American manufacturing. Fisher had retooled their facilities for tank production in 1942, and by 1944, they were one of the most efficient Sherman manufacturers in the country. The Fisher engineers faced an extraordinary challenge. The Army wanted 254 assault tanks delivered by August. That meant designing the armor modifications, developing production processes, manufacturing the components, and completing final assembly in less than 5 months. For context, typical tank development programs took years. The design team, led by engineers who had spent the previous 2 years perfecting Sherman production, went to work immediately. The basic concept was straightforward, but the execution required careful metallurgical calculation. They would add 1.5 inches of rolled homogeneous armor plate to the M4A3's frontal hull and sides, increasing protection from 2.5 inches to 4 inches on the glacis plate, and from 1.5 inches to 3 inches on the sides. But armor thickness alone didn't tell the complete story. What mattered was effective thickness, the actual protection provided when you accounted for the angle of the armor plate. The M4A3E2 used the newer large hatch hull with a glacis plate angled at 47 degrees from vertical. When an 88mm shell struck that angled 4-inch plate, it had to penetrate the equivalent of nearly 6 inches of steel. To put that in perspective, the German Tiger I heavy tank had frontal armor of 102mm, roughly 4 inches. The Sherman Jumbo's effective frontal armor would equal or exceed the Tiger's protection. An American medium tank, modified in a matter of months, would have armor comparable to Germany's most feared heavy tank. The hull modifications were only part of the protection package. The turret required even more extensive work. Fisher engineers designed an entirely new turret, casting based on the T-23 turret that would later be used on 76mm gun, Shermans, but significantly up-armored. The new turret had armor 6 inches thick on all sides. Front, rear, and side walls all received 152mm of protection. This was equal to the frontal glacis plate of the Tiger II, Germany's newest and most heavily armoured tank. The turret sides alone had more armour than the Tiger I's frontal plate. The gun mantlet received special attention. Fisher engineers welded an additional 130mm of steel plating onto the standard 50mm thick mantlet, creating a combined thickness of 180mm. From the front, the Sherman Jumbo would be nearly invulnerable to most German anti-tank weapons. The differential housing, the armoured cover protecting the final drive at the very front of the hull, was replaced with a massive casting. Where the standard Sherman had a differential housing, with 101mm of armour at its thickest point, the Jumbo's housing measured 140mm. This wasn't welded on appliqué armour. The extra thickness was cast directly into the component, making it structurally integral. All this armour created a tank weighing 84,000 pounds, 42 tons, nearly 10 tons heavier than a standard M4A3. The mechanical modifications needed to handle this weight demonstrated the depth of American automotive engineering expertise that Fisher brought to the project. The final drive ratio was increased from 2.84 to 1 to 3.36 to 1. This reduced top speed from 30 miles per hour to 22 miles per hour, but it allowed the engine to move the extra weight without burning out. More importantly, it maintained reasonable acceleration. A tank that couldn't accelerate quickly would be a sitting target. To manage ground pressure and prevent the tank from sinking into soft terrain, Fisher engineers added extended end connectors to the tracks. These duckbills were metal extensions fitted to the outside edge of each track link, widening the track from 16.7 inches to over 20 inches. The wider tracks increased ground contact area by nearly 10%, keeping ground pressure at 14.2 pounds per square inch. For comparison, a standard M4A3 without duckbills had ground pressure of 13.7 pounds per square inch. The heavily armoured assault tank would have only marginally higher ground pressure than the vehicle it was based on. Every modification was carefully calculated to maintain the Sherman's fundamental reliability while maximising armour protection. The Ford GAA V8 engine remained unchanged. It was a proven power plant, a 500 horsepower engine developed specifically for the M4A3. The engineers knew it could handle the extra load. The suspension used the standard vertical volute spring suspension system found on other Shermans. The Army warned crews that cross-country performance would be reduced and that they should avoid extreme terrain that might overstress the suspension. But in testing, the suspension proved more robust than initially feared. What made the entire project possible wasn't just clever engineering, it was the quality of American armor steel. The rolled, homogeneous armor plate used on the Sherman Jumbo represented decades of metallurgical development that had created steel with a nearly perfect balance of hardness and ductility. The armor plate manufacturing process began at steel mills that had been producing high-quality alloy steel since before the war. Carnegie Steel, Bethlehem Steel, Republic Steel, and others had spent years perfecting nickel-chromium steel compositions that could be rolled into plate and heat-treated to achieve specific properties. The steel composition mattered enormously. American armor plate typically contained roughly 3 to 4% nickel and 1 to 2% chromium, with carefully controlled carbon content around 0.3%. The nickel and chromium created an alloy that was both hard and tough, able to resist penetration without shattering. The manufacturing process involved rolling the steel while hot, which improved the grain structure and removed internal weaknesses. After rolling to the required thickness, the plate was tempered and annealed. Tempering involved heating the steel to a specific temperature and then cooling it in a controlled manner. Annealing relieved internal stresses in the metal. These heat treatment processes were critical. Too hard, and the armor would shatter under impact, sending deadly spall fragments into the tank's interior. Too soft, and shells would penetrate more easily. American metallurgists had spent years determining the optimal hardness levels for different armor thicknesses. For armor plate less than 32 mm thick, American specifications called for Brinell hardness numbers of 302 to 325. For thicker plates between 76 and 127 mm, the specification was 240 to 260. The thickest plates, over 127 mm, were tempered to 220 Brinell hardness. The decreasing hardness with increasing thickness wasn't a limitation. It was intentional engineering. Thicker plates didn't need to be as hard because the shell had to penetrate more material. By keeping the hardness lower, the steel remained more ductile, more resistant to cracking, and actually performed better against the heavy shells that could threaten thick armor. American testing in 1942 and 1943 had demonstrated the quality of this armor. Test firings using 75 mm guns showed that American rolled homogeneous armor was 10 to 20% more resistant than cast armor of the same thickness. The rolled armor could be brought to higher hardness levels without becoming brittle. The alternative was cast armor, used on the M4A1 variant with its distinctive rounded hull. Cast armor was faster to produce because it eliminated much of the welding required for a hull made of rolled plates, but cast armor was metallurgically inferior. The casting process created a homogeneous structure all the way through the armor, without the refined grain structure that rolling provided. American armor engineers accepted cast armor's limitations for production reasons, but they knew rolled plate was superior. For the assault tank, where every bit of protection mattered, Fisher Body used rolled plate for the additional armor. The welded plates on the glacis and sides were rolled homogeneous armor of the highest quality. This armor had another critical advantage. It was resistant to spalling and cracking. When a shell hit but failed to penetrate, American armor plate absorbed the energy without sending showers of steel fragments into the crew compartment. German armor, particularly late-war plate manufactured with inadequate alloys, often spalled badly even when it stopped the penetration. The difference came down to the combination of hardness and toughness. American steel was tough enough to yield slightly under impact rather than shattering. This toughness meant the armor could take multiple hits without developing cracks that would weaken its protection. Sherman crews in Europe had already discovered this quality. There were numerous accounts of Shermans that had been hit multiple times. The armor dented and scarred but still intact. The crews had survived because American armor, while not as thick as German heavy tank armor, didn't fail catastrophically. Now, with the Sherman Jumbo, that reliable armor steel would be present in thicknesses that matched or exceeded German heavy tanks. The combination of superior metallurgy and greater thickness would create protection that even the dreaded 88 mm gun would struggle to defeat. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The pressure on Fisher Body Division in the spring of 1944 was immense. The Grand Blanc tank arsenal needed to design production tooling, source additional armor plate, train workers on new welding procedures, and manufacture 254 assault tanks in less than 4 months. The standard timeline for introducing a new tank variant was measured in years, not months. The Ordnance Department understood the challenge. In an extraordinary decision that revealed the desperation behind the project, they informed Fisher Body in late March that, in order to expedite delivery of the M4A3 assault tanks, certain requirements of applicable specifications will be waived for the total of 254 vehicles. This was unprecedented. The government was essentially telling Fisher Body, "We trust you to build these tanks correctly without the normal testing and inspection regime." The usual quality control procedures that could take weeks or months were being bypassed. If the tanks proved defective, Fisher would still be paid for all 254 experimental vehicles, even if they never saw combat. The decision reflected both confidence in Fisher's capabilities and acknowledgement that time had run out. D-Day was scheduled for early June. The tanks needed to be in production immediately, not after weeks of bureaucratic approval processes. Thomas Beckwith and his engineering team worked 18-hour days through March and April. Every aspect of the armour modifications required detailed planning. The welding procedures for attaching the additional armour plate had to be perfect. A flawed weld could create a weak point where a shell might penetrate or cause the armour to crack under impact. The team developed specific welding sequences to minimize warping from the heat. Large armour plates, when welded to a tank hull, could distort the underlying structure if the welds weren't properly sequenced. The welders would work in specific patterns, allowing sections to cool before moving to adjacent areas, distributing the thermal stress evenly. The additional armour for the hull sides was applied in 2 separate pieces rather than a single large plate. This decision, which seemed like it might create a weakness, actually made the armour more structurally sound. The 2-piece design distributed stress more effectively and reduced the likelihood of catastrophic failure if one section was penetrated. The turret presented even greater challenges. The new turret wasn't a modification of an existing design. It was an entirely new casting that had to be designed, patterns created, and the casting process perfected. The 6-inch armour thickness required massive moulds and careful control of the cooling process to prevent defects in the casting. Unlike standard Sherman turrets, which were cast as a single piece, the jumbo turret roof was made from 2 separate plates welded into the gap created by the cast sides. This modification was necessary because of the extreme thickness of the turret walls. Casting a complete turret with 6-inch walls and an integral roof would have created metallurgical problems during cooling. Production began in May 1944. The Grand Blanc tank arsenal transformed into a focused production machine. Workers who had been building standard M4A3 Shermans adapted to the new procedures. The welding teams practiced on scrap sections until they could produce flawless joints. The assembly line incorporated the additional steps needed to install the heavier armour. The factory operated around the clock: first shift, second shift, third shift. The workers understood what was at stake. Many had sons, brothers, husbands in the army. The tanks they were building would protect American soldiers storming the beaches of France. Every weld had to be perfect, every bolt properly torqued, every component installed correctly. The pace was extraordinary. Standard tank production already operated at impressive speeds, but the jumbo program pushed beyond normal limits. Engineers solved problems on the fly. When a casting defect appeared in early turret production, metallurgists adjusted the cooling process overnight. When alignment issues emerged during hull assembly, new fixtures were fabricated within days. By July 1944, all 254 M4A3 assault tanks had been completed. The production run had taken just over 2 months. Fisher Body had achieved what many had considered impossible. They had designed, tooled, and manufactured a heavily armoured assault tank in less time than it typically took to make minor modifications to existing designs. Each tank bore a small brass identification plate with its serial number and the Fisher Body name. Workers had written messages on hidden interior surfaces. "Good luck to the crew. Bring 'em home safe. Give the Germans hell." These small gestures revealed that the men and women building these tanks understood they were doing more than manufacturing. They were sending protection to soldiers who would face death on European battlefields. But the tanks were too late for D-Day. On June 6, 1944, American forces stormed the beaches of Normandy in standard Shermans. The delay wasn't Fisher Body's fault. Even with their remarkable production speed, there simply hadn't been enough time to get assault tanks to England before the invasion. The jumbos remained in the United States through the summer, undergoing final acceptance testing at Aberdeen Proving Ground and being prepared for shipment. On June 8th, a jumbo with serial number 30326, Army registration number USA 30822957, arrived at the Chrysler Tank Arsenal Proving Ground in Detroit for endurance trials. The test crews put the tank through punishing exercises. They ran it cross-country over rough terrain. They tested it in mud, on hills, through water obstacles. They fired the gun repeatedly to verify the fire control system worked properly with the heavier turret. They pushed the engine to its limits to confirm it could sustain combat operations. The tank performed well. The suspension handled the weight without excessive wear. The engine temperatures remained within acceptable limits. The transmission, with its modified final drive ratios, moved the 42-ton vehicle with reasonable agility. Most importantly, the armor welds showed no signs of cracking or failure. By September 1944, the first jumbos were crossing the Atlantic. They arrived at French ports still held by Allied forces and were transported by rail and tank transporter to forward depots. On October 14th, the United States First Army received the first 36 M4A3 tanks. The crews who first saw these new Shermans were immediately struck by their appearance. The jumbo looked substantially different from a standard Sherman. The thicker armor was immediately obvious, the massive turret with its vertical sides rather than the sloped casting of standard Shermans. The prominent gun mantlet that protruded from the turret front. The extended track connectors that gave the tank a wider, more aggressive stance. Lieutenant James Bates, a platoon leader with the 743rd Tank Battalion, walked around one of the newly arrived jumbos with a mixture of awe and hope. He had lost friends to German anti-tank guns. He had seen Shermans brew up after 88mm hits, the ammunition cooking off, the crews sometimes trapped inside. The idea of armor that might actually stop an 88 seemed almost too good to be true. He rapped his knuckles against the turret armor. The metal rang with a solid, reassuring thunk. How thick is this? The ordnance sergeant consulting his paperwork looked up. 6 inches all around the turret, sir. 4 inches on the glacis, with the angle figured in. It's the equivalent of nearly 6 inches. Gun mantlet is 7 inches. This thing's got more armor than a tiger. Bates felt a weight lift slightly from his shoulders. When do we take them into action? Soon as you're checked out on the modifications, sir. They want these leading the attacks. That was the tactical doctrine that had evolved around the jumbo even before the first tanks reached Europe. American tank formations typically moved in columns when approaching enemy positions, presenting smaller targets and allowing for rapid deployment once contact was made. The problem was that the lead tank, the point vehicle, absorbed the first enemy fire and often didn't survive. With the jumbo's arrival, that changed. The heavily armoured assault tank would take the point position. It would absorb the first shots. The armour that would destroy a standard Sherman would, hopefully, bounce off the jumbo's thick plates. Once the enemy position was revealed by their fire, the column could deploy and bring superior numbers to bear. The tactics worked even better than hoped. The first combat reports from units equipped with jumbos were enthusiastic. Tank commanders who had previously dreaded taking point were now volunteering for the position. The psychological impact of knowing you had real protection, armor that might actually save your life, transformed how crews approached combat. One of the earliest documented encounters occurred near Aachen in October 1944. A jumbo from the 743rd Tank Battalion was leading a column advancing through rubble-strewn streets when a German Pak-40 anti-tank gun opened fire from a concealed position. The 75mm armor-piercing round struck the jumbo's glacis plate with tremendous force. Inside the tank, the crew felt the impact as a violent jolt. The sound was like a massive hammer striking an anvil, but the shell didn't penetrate. It ricocheted off the angled armor, leaving a deep gouge in the steel but not breaking through. The gunner, already traversing toward the enemy position, fired the 75mm gun, The high explosive round silenced the German gun. The crew dismounted after securing the area to examine the damage. The impact point showed where the shell had struck and deflected upward. The armor was scarred but intact. No penetration, no spalling inside the crew compartment. The jumbo had done exactly what it was designed to do. More dramatic encounters followed. Near Geilenkirchen in November 1944, a jumbo survived multiple hits from a German 88mm gun. The tank was advancing across open ground when the 88 opened fire from a camouflaged position roughly 800 meters away. The first shot struck the turret, creating a tremendous crash but failing to penetrate the 6-inch armor. The commander, momentarily stunned by the impact, recovered quickly. Driver, hard right. Gunner, 11 o'clock, tree line. The second shot hit while the tank was turning, striking the side armor. Again, no penetration. The 3-inch side armor, while thinner than the frontal protection, was still thick enough to defeat the 88 at that range and angle. The gunner fired on the suspected position. The Sherman's 75mm gun wasn't as powerful as the German 88, but it was accurate, and the crew was well trained. High explosive rounds pounded the tree line until the enemy gun was silenced. When the crew examined their tank afterward, they counted 4 impact points, 4 hits from an 88mm gun, 0 penetrations. The tank was still fully operational. In a standard Sherman, any one of those hits would likely have been fatal. The most famous jumbo, however, earned its place in history, not through a dramatic gun duel, but through a desperate race to save surrounded American troops. The tank's name was Cobra King, and its moment came during the Battle of the Bulge. In December 1944, German forces launched a massive surprise offensive through the Ardennes forest. American units were caught off guard and fell back in confusion. The 101st Airborne Division found itself surrounded in the town of Bastogne, a critical road junction that the Germans needed to maintain their advance. The paratroopers held Bastogne against overwhelming odds, but they were running low on ammunition, medical supplies, and food. Weather prevented air resupply. The situation was desperate. General Patton's Third Army launched a relief offensive, driving north through fierce German resistance to break through to the surrounded troops. On December 26, 1944, elements of the 4th Armoured Division fought their way to the outskirts of Bastogne. The lead tank of the relief column was Cobra King, a jumbo from the 37th Tank Battalion, commanded by First Lieutenant Charles Perry Boggess. Boggess had been carefully selected to lead the breakthrough attempt. He was experienced, aggressive, and his crew had trained extensively on the jumbo. Most importantly, his tank had the armor to survive the gauntlet of German anti-tank weapons that would surely target the first American vehicle to break through. The column moved out in the pre-dawn darkness, headlights off, moving by moonlight and the ambient glow of artillery fire. German positions detected the movement and opened fire. Shells crashed around Cobra King. Boggess kept the tank moving, pushing forward through the fire, trusting the armor to protect his crew. A Panzerfaust, the German handheld anti-tank weapon, detonated against the side armor. The shaped charge warhead, designed to burn through steel with a jet of superheated metal, left a blackened crater, but didn't penetrate. The 3-inch side armor, with its tough, resilient American steel, absorbed the blast. Machine gun fire rattled against the hull. Small arms rounds sparked harmlessly off the thick armor. The German infantry, seeing a Sherman charging through their positions, fired everything they had. None of it mattered. The jumbo's armor shrugged off weapons that would have destroyed a lighter tank. At approximately 4:50 in the afternoon, Cobra King reached the American lines at Bastogne. Boggess, taking no chances, called out to the troops he could see in the gathering darkness. "We're the 4th Armoured Division." After several exchanges, an officer emerged, Lieutenant Webster of the 326th Airborne Engineers, with a smile that came from deep relief. "Glad to see you guys." The siege of Bastogne was broken. Cobra King had led the relief force through miles of enemy-held territory, absorbing fire that would have stopped a standard Sherman and delivered hope to thousands of surrounded paratroopers. The jumbo's armor had made the breakthrough possible, But not every encounter with German guns ended favourably. The jumbo was formidable, but it wasn't invincible. At Fraunhofen in Germany, a jumbo from the 743rd Tank Battalion struck an anti-tank mine that disabled its tracks. Immobilized, the tank became a stationary target. A German 88mm gun, whether a tank gun or an anti-tank gun, the crew never determined, opened fire on the helpless vehicle. The gunner was skilled and persistent. 8 times, 88mm shells struck the jumbo. The crew, unable to move, could only wait and hope the armour held. 7 of the shots ricocheted or failed to penetrate. The armour, even under concentrated fire from one of Germany's most powerful anti-tank weapons, performed as designed. But the 8th shot found a weakness. It struck just above the side sponson, slightly above the tracks, where the side armour was thinner and the angle less favourable. The shell, it penetrated. The crew bailed out immediately, expecting the worst, but the internal damage was less than they feared. The wet ammunition stowage, a modification that jacketed ammunition in water and glycerin, prevented the catastrophic ammunition fire that had claimed so many earlier Shermans. The tank was disabled, but the crew survived. Even this incident, which represented a jumbo's failure, actually demonstrated the success of American armour engineering. A tank that took 8 hits from an 88mm gun before being penetrated had performed far beyond what any standard Sherman could have achieved. The crew lived because 7 out of 8 hits failed to penetrate armour that, by German standards, shouldn't have been able to stop even one. Combat reports compiled through late 1944 and early 1945 consistently praised the jumbo. Unit commanders wanted more. General Patton himself, commanding the Third Army, issued orders in January 1945 requesting additional assault tanks for his forces. Patton had previously banned his units from adding sandbags and wooden logs to their tanks, correctly noting that these field modifications provided minimal protection while adding weight and reducing mobility. But when he learned about the jumbo's performance, he immediately recognized its value. When told that no more jumbos were in production, that the original order for 254 had been a limited run, Patton characteristically refused to accept the limitation. He ordered his unit commanders to create makeshift assault tanks using armour salvaged from knocked-out vehicles. Third Army maintenance units began an unusual modification program. When a Sherman was knocked out and couldn't be recovered, but its armour was intact, welding crews would cut off the frontal glacis plate. These plates, weighing hundreds of pounds, would be transported to forward maintenance areas and welded onto operational M4A3 tanks. The field modifications weren't as extensive as factory-built jumbos. The units couldn't add the massive cast turret or the thickened differential housing, but welding an extra 2.5 inches of armour plate onto the glacis provided significantly improved frontal protection. The modified tanks, sometimes called field jumbos, gave crews better odds of surviving frontal hits. Approximately 100 to 200 Shermans received these field armour upgrades. The modifications were crude compared to Fisher Body's precision work, but they were effective. Tank crews appreciated any additional protection, and commanders noted that tanks with extra armour could be used more aggressively. One famous example was the M4A3 76mm Thunderbolt 7, commanded by Colonel Creighton Abrams. Abrams, who would later become Army Chief of Staff, was an aggressive tank commander who understood the value of protection. His tank featured multiple layers of additional armour, including sections of hollow steel welded to the sides to provide standoff protection against Panzerfausts. The field modifications demonstrated that the jumbo concept was sound. Commanders wanted heavily armoured assault tanks, crews wanted the protection. The tactical benefits were clear, but production had ended. The war in Europe was entering its final phase, and military planners were focused on the new M26 Pershing rather than additional jumbo production. In early 1945, as American forces pushed into Germany itself, a request was submitted for an improved jumbo variant. This new version would mount the 76mm M1 gun, providing better anti-tank capability and would use the newer horizontal volute spring suspension system for improved cross-country performance. The request was later modified to include using the turret and 90mm gun from the M26 Pershing, essentially creating an assault tank with jumbo-level armor and Pershing-level firepower. Engineering work began on what was designated the T-26E5 assault tank, but by the time the T-26E5 design was complete,